Hello guys, you're welcome. This is MJ with MBJ Knowledge. If you're new to this channel, make sure you subscribe and hit the notification bell so that you don't miss out any video that we are going to drop. So today we have a lesson under earth geometry, and we've gotten a question from a past paper which we are going to handle together. Okay, so stay tuned. Alright, so the question is saying the points A, B, C, and D are points on the surface of the earth. We've been given radius of the earth as 3437 nautical miles. Then pi is 3.142. This is the earth's surface. Okay. The first question is saying find the difference in longitudes between the points B and C. We are finding the difference in longitudes between points B and C. When you look at the points B and C, they are here, B and C. These points are on the same latitude, which is the 50 degrees south. Hence, they are on different longitudes. Okay, so to find the difference in longitudes, you will look at B is seated on longitude. This is a longitude, okay, by the way. These lines that are running from north to south, these are longitudes, and then these are latitudes. So you only have two latitudes and the three longitudes, okay? So B is seated on longitude D, 52 degrees east, and C is seated on longitude D, 73 degrees west. So to find that difference, remember this, when you have different poles, okay? So different poles, always different poles you add, okay? So in this case, when you look at B is on the east, C is on the west. So the poles are different, west, east. So we are going to add these longitudes. So the difference in their longitudes, that is question Roman numeral 1, will just be 52 plus 73. Okay, so just adding those, okay, use a calculator, you can add there. Okay, so 52 plus 73, we have 125 degrees. This is their difference in their longitudes. Okay, it means you are done there. 2 marks for that. Then we come to question 2. Calculate the distance in nautical miles of AB. Okay, calculate the distance in nautical miles of AB. So AB is this. This is our A and this is our B here. So this is the distance from A coming to B. Okay, what is that distance? When you look at the 2 points A and B, they are seated on the same longitude. Okay, meaning if they're in the same longitude, it means they will be on different latitudes. So A is on latitude 70 degrees north, B is on latitude 50 degrees south. The longitude where A and B are seated on is longitude 52 degrees east. So since they are on the same longitude, okay, calculating their distance, the formula will be, theta over 360, okay, 2 pi r. Now, why am I ending here? All longitudes, okay, all longitudes are great circles. When we say great circles, we simply mean their radius from the center of the earth. Let me just say the radius of these longitudes is the same as the radius for the earth. Okay, so that is why they are called great circles. No wonder their formula. This is the formula when you're calculating distance along the longitudes. Where A and B, they are seated on the same longitude, meaning we are calculating distance along their longitudes. So here, our theta, so on the data here, okay, on the data here, theta is going to represent their difference in their latitudes. So in this case, A is on 70 degrees north, B is on 50 degrees south. We say the different poles, north, south, we're supposed to add. So we're going to add 70 plus 50, okay? So 70 plus 50, where we have 120 degrees, okay? That is their difference in latitudes, okay? Then the radius we've been given, the pi is there, Okay, so let us substitute. So we're going to have 120 divided by 360 times 2 times pi. This is the value for pi, so 3.142, okay, times the radius is in nautical miles, that is 3437, okay. All right, so we can calculate now. Okay, so we multiply everything on top, so that is 120 multiplied by 2 multiplied by 3.142 multiplied by 3437. Okay, so we are having a value as 2591. No, okay, so 2591, then 77, then 2.96. Everything here will be divided by 360. Okay, so this is the distance AB, by the way. So AB will be equal to this value, we divide it by 360, where we're going to get 7199.369333. In case you don't know how to round off, okay, in case you don't know how to round off, just put your units here and you end there. That is the correct value. But in case you do know how to round off, we're supposed to round off our value to 3 significant figures. So 1, 2, 3, we'll end here. Okay, we'll get a 1 from a 9, add it here, it becomes a 10, so this will be a 0. Okay, carrying a 1 to this will be a 2. So it will be 7, 2, 0. This number, it is before the point, so it is going to turn into a 0 in a nautical miles. Okay, so that is the value there for AB. That is the distance, 7,200 nautical miles. That is the distance from A to point B there. Okay, we go to calculating the distance in nautical miles of CD. Okay, so B, we've been given CD. Okay, so let us check CD. CD. When you look at where C and D are seated on, they are in the same latitude. Okay, so now we are not calculating distance in longitudes. It is different from this. Okay, we're calculating distance in along the latitude. Okay, because C and D, they are in the same latitude. All right, so the formula will be different. When you're calculating distance in latitudes, the formula is different. Okay, theta over 360, okay, times 2 pi r. Now, because this latitude here, it is not a great circle. Okay, the only latitude which is a great circle is an equator, the 0 degrees. But this one is not 0 degrees, meaning it is not a great circle. So small circles, you on the formula for distance here put cos alpha. Okay, so this is representing or it is showing that this is not a great circle. The reason is that all the small circles, their radius is not equal to the radius of the earth. Okay, so let us substitute. Now, on the theta here, we are going to have their difference in their longitudes. Okay, because C is on longitude 73 degrees west, D is on longitude 31 degrees west. Okay, so in this case, because we've got similar poles, we find the difference in their longitudes. So here we're going to say 73 minus 31. Okay, so we're going to say 73 minus 31. Okay, 73 minus 31, where we get a 42. So the difference is a 42. We're subtracting because the poles are the same, west, west. Okay, then the alpha in that case, the alpha here is just the latitude where they're seated on. So C and D, they're seated on latitude 50 degrees south. So 50 is the value for our alpha here. So let us now substitute our values. Okay, so we have theta, which is 42, okay, over 360 times 2 times our pi is 3.142, Okay, 142 times our radius, since we're finding distance in nautical miles, times the cos 50 degrees. Okay, so you can multiply everything on top. So we have 42 times 2 times 3.142. Okay, times 3.142 times 3437. Okay, so here we're going to have 583.085. Okay, this is a comma, then point here 841. Then everything there divided by 360. Okay, so divide that value by 360. You're going to have, okay, the distance CD as 1619.682892. As I've said, if you can't manage to round off, just leave it like this. Put your units there. Okay, but if you are able, you can round off to 3. 1, 2, 3. Strike here. Okay, so we are striking here. Okay, the next number here is greater than 4, so we can add the 1. So it will be 162. Then this is before the point, so it is going to change into a 0. Then the rest will remove in nautical miles. Okay, this is the distance between C and D in nautical miles. So thank you very much, guys, for watching. Please stay tuned and don't forget to share the video and like it and comment if you enjoy it. See you in the next video.